In today's video, we are going to cover Chapter 11, Section 4, Areas of Kites and Related Figures. After studying this section, you will be able to find the area of kites. So remember that in a kite, the diagonals are perpendicular, meaning they form right angles. Also, a kite can be divided into two isosceles triangles with a common base. So its area will equal the sum of the areas of these triangles. So if I look at my figure to the right, what that means is I can split this kite into two different isosceles triangles, isosceles triangle ADB as well as isosceles triangle CBD. So by looking at those two separate triangles, I would get the area of a kite is equal to the triangle ABD plus the triangle DBC. Notice the triangle ADB formula for a triangle is 1/2 base times height. So my height here is AE, and then my base would be DB. So the area would be 1/2 BD times AE. And then the area of my triangle CBD would be 1/2 the height of CE times the base of DB. Then I can factor out my 1/2 BD from both of my area formulas, which would give me 1/2 BD times AE plus EC. And notice if I highlight AE and EC, that's my whole length of AC. So then my formula can become 1/2 BD times AC. And if you look, BD and AC are my diagonals. So that gives me this following formula for the area of a kite. The area of a kite equals half the product of its diagonals, where D1 is the length of one diagonal and D2 is the length of the other diagonal. This formula can be applied to any kite, including special cases of rhombuses and squares. Looking at some examples, we have problem 1, find the area of a kite with diagonals 9 and 14. So I know the area of a kite is 1/2 diagonal 1 times diagonal 2. If I substitute in 9 and 14 as my lengths for diagonal 1 and diagonal 2, I will get 1/2 times 9 times 14. So the area of this kite will be 63 units squared. Looking at problem 2, find the area of a rhombus whose perimeter is 20 and whose longer diagonal is 8. Now if I draw a rhombus, remember in a rhombus, all my sides are equal. So if my perimeter is 20 and I have 4 sides, that means the side length is 5. The diagonals of a rhombus are perpendicular to each other, so they form right angles, and they also bisect each other. So if one of the diagonals is 8, that means both lengths are 4. Notice I can find my other diagonal length by using the Pythagorean theorem. So I have a right triangle with a hypotenuse of 5 and a side length of 4. This is a Pythagorean triple of 3, 4, 5. So my other half diagonal length would also be 3. So I have a full diagonal length of 6. So using the area of a kite, I have 1/2 diagonal 1 times diagonal 2. In this case, my two diagonals were 6 and 8. So 1/2 times 6 times 8. 1/2 of 6 times 8 is 24 units squared. So the area of this kite is 24 units squared. In this lesson, we learned the area of a kite is defined as area equals 1/2 times diagonal 1 times diagonal 2. That's a wrap on this video. We'll see you in the next one.